Okay. So we are having the theorem which says that if two equal chord of a circle intersect within the circle, prove that the segment of one chord are equal to corresponding segment of the other chord. So if we are having a circle like this, let me draw the figure. Figure is not given over here. We need to draw it by ourselves. Okay, I am taking a bigger circle. Now here the theorem says if two equal chord of a circle intersect within the circle. So there are two equal chord which are intersecting within the circle. This is the chord we are having and this is the chord we are having, and it is intersecting as you can see within the, or I would take in a like this and like this. Both are intersecting within the circle. Prove that the segment of one chord are equal to the corresponding segment of the other chord. So let's say this is the chord AB. Let's say this is chord MN. Okay. Here we are having the center of the circle O. We can drop the perpendicular from the center on this chord, and we can also drop the perpendicular from the center on this chord. Okay. Now we have to prove that, let me write what we have to prove over here. We have to prove that if this is the point of intersection, that is, let's say T, we have to prove that this AT is equals to NT, and the other segment, the other part of the segment, TB is equals to TM. Okay. The corresponding, the bigger segment over here is equals to bigger segment over there. The smaller segment over here is equals to a smaller segment over there. That's what we have to prove. Okay. Now we know that these two chords are of equal length. AB and MN, these two chords are having same length that is given in the question itself. Okay. Let's prove it. Just a second. Let's see how can we prove. So here we can do one construction at first which will help us to prove it. Okay. Before doing the construction, we know here everyone can see my screen, right?
Yes.
Okay. So we know that here we are dropping the perpendicular from O. So let's say this is the point. Let's say this is the point S. This is the point P. So once we have dropped the perpendicular OS on the chord AB, so we know here, we can write here that AS and BS will be same. However, it doesn't look like that in the figure, but it is same. Once we are dropping the perpendicular from the center, it will bisect the chord, right? Right? Similarly, here I am saying that OS is perpendicular on AB and hence AS, BS are same. Similarly, I would write here that OP is perpendicular on MN and hence uh, MP and NP will be same. Okay, this is equation number 1. This is equation number 2 we are having. Is it clear so far? We have just dropped the perpendicular and we have used the theorem that perpendicular drop from the center of the circle on the chord bisects the chord. Okay, that's what I have taken over here, nothing else. Now I would say that it is given over here that AB chord and MN chord are of same length. So half of AB and half of MN will also be same, right? Right? So half of AB means I can take AS. Half of MN means I can take MP, or half of AB we can also take it as a BS. Half of MN we can take as a, again MP we can take, or NP also we can take. So eventually can I say that AS, BS, MP, NP all will be of same length? Can we say?
Yeah.
Yes, we can say that AS, BS, MP, NP all are having same length. Now let's get back to our proof. Okay, we have to prove that AT is equals to NT. Let's give it a name. Equation number 3. Okay, AS, BS, MP, NP all are same. Now AT is equals to NT. That's what we have to prove. If we will drop a perpendicular from here, can we prove this two triangle or congruent triangle? I'm talking about this triangle and this triangle. Can we prove these two are congruent? Yes or no? The yellow one and the green one. Here we are having a common side OT. Okay. OT common side we are having. What else we are having? We can see 90° over here and 90° over there. So there is a 90° which is there in both the triangle. And what else? Anything else? Anything else? Equal chord are at equidistant from the center. This distance and this distance will be same. Yes or no? Yes or no? Yesterday only we have discussed this theorem. Equal chord are equidistant from the center. So OP and OS will be same. Equal chord, equidistant from center. Okay, I'm not writing it like you have to, the way I'm explaining it over here, you can add the hint in your copy, or you can write it properly in your copy the way we are discussing it over here. Okay, we have to prove this yellow triangle and the green triangle is congruent triangle, and these are the three information which we can use to prove this two as a congruent triangle. Once we will be able to prove this two as a congruent triangle, now we can say that PT and ST will be of same length. Okay, we will be able to say that side PT and side ST both will be same by CPCT. Okay, now we are having equation number 3. We are having PT, ST same. Okay, So equation number 3 we are having as AS, BS, MP, NP all are same. So let's use this information. We are saying that PT is equals to ST. Let me write it over here so that we can keep our eyes on the figure. We are saying PT is equals to ST, that we have got by CPCT, and we also know that AS, BS and PNP, MP all are same, that we have already found. Okay. Now let's see what can be done over here. So can we say PT plus NP is equals to ST plus AS? Can we say? We are just adding equal. This and this are equal, and here we are adding equal on both sides. Okay. We are using this starred relation. PT is equals to ST. Here on both the side we are adding, one side we are adding NP, on other side we are adding AS. Why? Because AS and P both are same. Equal can be added to equal and the remaining, the whole will be equal. That's what Euclid said, right? Right? Are you getting it? From here, can we say that AT is equals to NT? Can we? Are you getting it?
No, mom.
Yes or no?
No.
Okay, no. So I am saying let's do it properly. We are having a circle, okay? We are having one chord over here, we are having another chord over here, and we are dropping a perpendicular from O center on this chord, and we are dropping a perpendicular from center on this chord. And we are saying that this is the point P and this is the point S. We have dropped the perpendicular. Okay, let's write it properly. So now we can write that since OS is perpendicular on chord AB, therefore AS will be equals to BS. Okay, perpendicular dropped on the chord from the center, bisect the chord. That theorem we are using it. Okay, now similarly we can say that OP is perpendicular on the chord MN. Therefore, and same. This is equation number 1. This is equation number 2. We know that both the chords are of same length. AB and MN are of same length. Therefore, half of AB and half of MN will also be same. Half of AB means what? AS or BS we can take. Half of MN means NP or MP we can take. So eventually all will be equal to each other. Okay, AS, BS, MP, NP all we can take will be equals to each other. Let's write it. Or you can write that half of AB means AS and half of MN means NP. This is the case we are having. Equation number 3, or this one we can also write it as a half of AB, that means BS, and half of MN means MP. Okay, equation 4, or we can say all together are equal with each other. Once we are done with this one, is it clear so far?
Yes.
Yeah. Now we will be taking two triangle by joining the point of intersection and the center. Okay, here let's say the point of intersection is T. So we are taking triangle POT and triangle SOT. Here I am saying that OS and OP will be same. Equal chord are equidistant from center. Are you getting it so far?
Yes.
Side I have written incorrectly. I must write OP over here and OS over there. OP on this side and OS on that side, because side triangle POT I have mentioned over here on the left side. Okay. Now I am writing that OT and OT is the common side. And there is a 90-degree over here, that is OPT is equals to OST. Both are 90-degree. Which congruency criteria is working here? Let's see. This angle I have used, this side I have used, and this side I have used. Again, RHS, right angle, hypotenuse, and one of the side. Okay, it is not SSA. SSA congruency criteria is not, it doesn't exist. So RHS. We can say by RHS congruency criteria, triangle POT is congruent with triangle SOT by RHS congruency criteria. From here, can we say that PT is equals to ST by CPCT? Yes, we can say that. Is it clear so far?
Yes.
Now, this is equation number, let's say 5. So what I am saying that let's take equation number 3 and let's add it with 5. So we will be having AS plus PT is equals to NP plus ST. AS plus PT is equals to NP plus ST. Can you see? We have just added equation 3 and equation 5. Let's see what are we getting. AS plus PT means what? Okay. Incorrectly I have added it. I must reverse the side and then I add. So from here I am saying that ST is equals to PT. Okay, we have written previously PT is equals to ST or ST is equals to PT. It's the same thing. Okay, X equals to 2 or 2 is equals to X. Both means X value is 2 only. Okay, why I am writing like this? So that we can add this with this one. Once we will add this to circled one, ASST, you can see we will be getting something in the figure. ASST, ASST, it is giving us 80. Can you see? That's why I have changed the side. So that we can add left hand side with left hand side and right hand side with right hand side. So the CPCT thing, I have written it reverse way, no worry. Side AB is equals to side PQ or side PQ is equals to side AB. It's the same thing. Okay. So we are adding these two equations and we are getting AS plus ST is equals to NP plus PT. Now you only check AS plus ST is what? Can you tell me? AS plus ST is what? AS plus ST is what? Can I say it is 80? This AS plus ST all together is 80. Can we say? Yes or no?
Wow.
Can be. Anyone having any doubt over here? Can we say it is 80? According to the figure, AS plus ST is 80 and NP plus PT. NP plus PT, if you will focus, it is NP, NP plus PT. It is what? It is MT, right? Let's write it. And that's what we wanted to prove, that that bigger segment over there is equals to bigger segment over here. Now we will be proving that a smaller segment over here in this circle, the segments we are having, the smaller part of the segment, this one is equals to a smaller part of the other segment. That's what we have to prove here, that bigger segment over here is equals to bigger segment. What is the meaning of the segment of the circle? Yesterday we have discussed that segment means we will be drawing a chord, and this is how we will be getting the segment. Okay, so once two chords are intersecting each other, this I can say that this is the bigger segment. I can say this one is the bigger segment. Here this one is the bigger segment. These two are equal, and this one is the smaller segment. These two are equal. That's what we have to prove. We have already proved that the bigger segment are equal. How we have proved that? First we are dropping the perpendicular. Now after dropping the perpendicular on the chord, we know the perpendicular will bisect the chord. We are writing accordingly that we have got the middle point. Accordingly, we are writing the cases. Now these two chords are of same length also. So we are getting that this section, that AT, this section, that is AS, BS, NP, MP, this all are same. After doing so, we are taking a triangle over here. We are doing one construction by joining the center to the point of intersection. And then we are taking two triangle and proving it congruent. After proving it congruent, we are getting that ST over there is equals to PT over here. Now we will be adding it with the previous case, and we will be getting the bigger segments are same. Here only we will be doing the subtraction, and we will be saying the smaller segments are also same. So let's see what can we do. So we know that ST is equals to PT, and we also know that equation number 3 says BS is equals to MP. So equation number 4 is BS is equals to MP, and equation number 5 is ST is equals to PT. Okay, if we will do the subtraction, 4 minus 5 if we will do separately, then BS minus ST is equals to MP minus PT. Let's see what are we getting. BS minus ST. Can you see it? BS minus ST. It is BT, right? BS minus ST is BT, right? BS is total minus ST. This one minus we have to do. So it is BT, right?
Yes, ma'am.
So we will be writing BT over there. And then we are having it is BT. And wait, yeah. Other side we were having MP minus PT. So let's see what is MP minus PT. MP is this total, and PT is only this much. So if we will do MP minus PT, we will be getting MT only. MT. And that's what we have to prove. These two blue ones are same. BT, MT are same. And these two AT and T are same. AT and T, the corresponding segments are same. Are you getting it?
Ma'am.
Please let me know whether it is clear or not.
Yeah.
Okay, how you are going to do it? Do you need to just memorize the steps? No, understand it like this, that we are having a circle. There are two equal chords. Okay, there is a point of intersection T. Here we must be having center. From center, we will be dropping the perpendicular. That perpendicular will bisect our chord. Okay. So we know that AB, and this is MN, and this is what we have taken accordingly. I am taking SP. This is SP. How you will understand, how you will keep in your mind that this is the process which we need to follow over here. So you can keep it like this, that first we'll be taking that this is perpendicular. That means middle point we got ASBS and NP, NP. This one is very simple. Dropping the perpendicular will give the middle point, and accordingly we are saying that our chord got bisected. Our chord is getting bisected. Accordingly we are writing this case. This case easily you will be able to write. Now the next step only you have to understand that the next step will be AB and CD both are same. That means half of AB and half of CD will be same. Okay, now we have to prove the segments are same, corresponding segment. That means our focus is completely on proving this blue one and this blue one, these two are same length. Okay, and we have to prove that this is smaller one and this is smaller one are also same length. This is what we wanted to prove over here. Okay, the segments, corresponding segments are same when the chords are intersecting each other, and the chords are, yes, equal chord. So we want to prove this blue one and this blue one are same. So from this blue one you can see one portion we are having AS over here. Okay, you can see we are having AS over there. We are having AS over here, and in this blue one we are having one NP over here. So if AB is equals to CD and half of AB is equals to half of CD, then we can say half of AB means half of AB we can take as a AS, right? And half of CD, sorry, not CD, MN, half of an MN we can take as a NP. Okay, a blue part from here is equals to another blue part from there. Or if this is also not clear, you can take that AS, BS, NP, MP, all will be same. Okay. Now you can proceed with the triangle concept. You can prove the congruency of the triangle. There, after proving the congruency of the triangle, for the first proof, these blue parts are same length. For this proof, you need to add this equation. Let's say this is equation number 1. You have to add this equation with the obtained CPCT, and for the other part proof you have to subtract this equation with that one. In the CPCT we have got that ST is equals to PT. This is what we have got in CPCT. Okay, again I am repeating. So once we have got this as a CPCT, I would say that ST plus AS is equals to PT plus NP. How I am writing AS and NP here? Because AS and NP both are same. So if equal are there, ST, PT both are equal. Euclid, there is a theory of Euclid, okay, which says that if two things are already equal, if we are sitting on the seesaw, okay, and already there is equal weight on both, 50 kg, 50 kg. Now if I'll keep 1 kg over here and 1 kg over here, still both will be equal. That's what Euclid says. Okay. So I am saying that if ST and PQ are same, then if you will add AS over here and NP over there, still remaining whole will be same. Why? Because AS and NP are same with each other. You can see in equation number 1, AS and NP are equal with each other. So you are adding equal quantity on both the side, and eventually it will remain equal. That's why I am giving this equality sign over here. That's why I am giving this equality sign over here. Getting it? Are you getting?
Yes, mom.
Now ST plus AS, ST plus AS means AT, PT plus NP, PT plus NP means NT. AT is equals to NT. We are done with the proof. Now again Euclid says that if ST is equals to PT, then if you will subtract equal quantity from here, if you are subtracting x from here and x from here, still both will be, it is valid. Okay, it is acceptable in mathematics. If you are subtracting same thing, if you are adding same thing. So now I am saying we are going to subtract. We are taking this equation. First thing first, let me take the equation. We are having this equation. Uh, yeah, equation number 1. Here I am going to use BS is equals to MP. I am going to use this case. BS is equals to MP. I am going to write it because all together are equal. So obviously BS is equals to MP. Now we are also having in hand ST is equals to PT. By CPCT, this one we are having in hand. We will do the subtraction. BS minus ST is equals to MP minus PT. You can see BS minus ST over here. BS complete one minus ST is nothing but just BT. Okay. Here we will be having BT and here we will be having MP minus PT. That means MT. Again, Euclid said that if two things are equal, BS and MP are equal, and if you are subtracting equal quantity or equal term from it, then the remaining will be equal. Again, the seesaw example, here 50 kg, there 50 kg. If I am removing 1 kg from here and 1 kg from there, still it will be in equilibrium. Okay, so that's what we are doing to prove it. Is it clear to everyone?
Yes, ma'am.
So this is how we will be proving this theorem. I want to take the next theorem also, but like today class is just, it's still 9:45. So I am keeping it this much. If you want to ask anything, please ask from me. If this is still it's not clear, please ask.